In this video, I'm going to explain the orthogonal complements. So the question that we have is find a basis for W tilde, where W is span of 1, -5, 2, 3 and 2, 1, 1, 1. So W tilde basically is the orthogonal component of W. So we denote orthogonal complement as W tilde, and therefore W tilde represents some vector x, which when multiplied or when found the dot product with these vectors gives you an answer 0. So this vector x dot product with this vector here, if that turns out to be 0, then we say that this is orthogonal. Similarly, the vector x dot product with this vector here, if that turns out to be 0, then we say that is orthogonal, right? So I'm going to write this in the form of an equation. So you have x1 1, right? 1 into x1 minus 5x2 plus 2x3 plus 3x4 equal to 0, and similarly 2x1 plus x2 plus x3 plus x4 equal to 0. So now these two equations can be written in the form of a matrix. So you have 1, -5, 2, 3 and 0 in the first row, and 2, 1, 1, 1, 0 in the second row. So basically, to find the orthogonality, we need to solve this matrix, right? So let's see how we can solve this matrix. So the first step is to convert the matrix into its row reduced echelon form, right? And so you can apply these operations r2 minus 2r1, r2 by 11 and r1 plus 5r2, and you end up with this matrix, which is the row reduced echelon form, right? And I've marked the pivot columns here, right? Now these pivot columns do not give us the free solution. In fact, it is the this column belonging to x3 and x4 which will give us the free solution. So let's assume x3 equal to some s and x4 equal to some t, right? So now looking at the rows, we can write x1 equal to, if I take x3 and x4 on the other side, on the right hand side, then this becomes minus 7 by 11 x3, and I'm assuming x3 as s, so minus 7 by 11 s, minus 8 by 11 x4. x4 is assumed to be t, therefore you have t. Similarly, you can write x2, which will become 3 by 11 s plus 5 by 11 t, right? So I'm going to write x1 and x2 and x3 and x4 in the form of a solution, or in the form of an equation. So x bar, the total vector, is nothing but minus 7 by 11 s. Then I'm going to take x2, which has 3 by 11 s. x3 is assumed to be s, therefore you have 1 here, and x4 is 0 because x4 is assumed to be t. Similarly, you write for t, you have minus 8 by 11, 5 by 11, x3 will be 0 and x4 is 1, right? So basically this will now form the basis for W tilde, right? We can simplify this basis further by just multiplying everything by 11. So once you multiply everything by 11, the basis just turns out to be minus 7, 3, 11 and 0, minus 8, 5, 0 and 11, right? So now can we confirm that this is basically the basis? Very simple. Take the vector x1, multiply with 1, -5, 3, 3. 1, -5, 3, 3 is nothing but the first vector which is given to us. So when you multiply x1 with 1, -5, 3, 3, that answer turns out to be 0. Therefore x1 dot this first vector is 0. Similarly, you take x2 dot product with that vector, that turns out to be 0, therefore they are orthogonal. So once you can you check your answer and they turn out to be 0, I can safely say that these two are the basis for W tilde, which is the orthogonal component of W.